The Sun is the biggest star in our solar system, with a distance of 7 lakh kilometers from center to surface. The Sun holds all the planets in their orbits, with its gravitational pull, and the source of energy for all life forms. Without the Sun, life would cease to exist on Earth as temperatures will plummet to extremely low levels. The core is the hottest part of the Sun, at 15 million degrees Celsius. Now, India is on a mission to research this biggest and hottest object in the solar system. How India is going to achieve this? By the end of this video, you have a full understanding of the ADITYA L1 mission. Let's get started. ADITYA L1. ADITYA L1 is the first space-based observatory-class Indian solar mission to study the Sun. The spacecraft is planned to be placed in a halo orbit around the Lagrange point L1 of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any oscillation or eclipse. What is Lagrange points? Lagrange points, also known as L points, are locations in space where gravitational force create equilibrium. There are 5 such points from L1 to L5. Why do we need to study Sun? The Sun is the nearest star and therefore can be studied in much detail compared to other stars. By studying the Sun, we can learn much more about stars in our Milky Way, as well as the stars of various galaxies. Observation of the Sun becomes necessary to track Earth-directed storms and impacts. Major objectives of ADITYA L1: to understand the coronal heating and solar wind acceleration, to understand the initiation of coronal mass ejection, flares, and near-the-Earth space weather. To understand the coupling and dynamic of the solar atmosphere. Why this mission is unique. This is the first time spatially resolved solar disk in the near UV band. It has onboard intelligence to detect CMS and solar flares for optimized observation and data volume, directional and energy anisotropy of solar wind using multi-directional observations. The mission has 7 highly advanced payloads, like visible emission line coronagraph for coronal imaging and spectroscopy, solar ultraviolet imaging telescope for photosphere and chromosphere, Adithya, solar wind particle experiment for solar wind particles analyze protons and heavier ions with direction plasma analyzer package, for Adithya, solar wind particles analyze electrons and heavier ions with direction, solar low energy X-ray spectrometer soft X-ray spectrometer, for the Sun as a star observation, high energy L1 orbiting X-ray spectrometer hard X-ray spectrometer, for the Sun as a star observation, advanced tri-axis, high-resolution, digital magnetometer, for the study of insight magnetic field. Key facts of ADITYA L1. ADITYA L1 will be exploring the Sun's secret on a 25-day journey. This mission will be ISRO's second space-based astronomy mission after ASTROSAT. If ADITYA L1 is successful, India will join the select group of countries that are already studying the Sun.